Hi gang, this is test one number 3E. So I had mentioned in the lecture that this one is a special case, all right? So let's go back through it. When you plug in a value here like 6, you'll notice you get 0 over 0. It's indeterminate. And I had explained in lecture when you have the same thing over the same thing, 5 over 5, 8 over 8, 10 over 10, that has a ratio of 1. That has a ratio of 1. Okay, it's the same thing over the same thing. The only thing you have to be careful of here, or something you have to be careful of here, is that the numerator is positive always, or wherever the absolute value is. The absolute value could be at the bottom. But since there's an absolute value here, the output of this side is always positive. And for the denominator, the output could be positive or negative, which means that if you have a positive over a positive, the ratio is going to be positive 1. But if you have a positive over a negative, then the ratio is going to be negative 1. So for instance, if x is 8, and I do 8 minus 6 over 8 minus 6, that's 2 over 2, which is 1. But if I have x equals to 4, then I have 4 minus 6 over 4 minus 6. But in the numerator, it's the absolute value of negative 2, which is going to make it positive 2. So the ratio for something like 4 is negative 1. So it can give out both these values. Where it's going to switch from positive to negative is where the function becomes 0 over 0 or indeterminate. So in other words, the jump occurs at 6 in this case. So let me just draw this for you because some of you are very visual. So if I plug in 6, it's indeterminate. If I plug in something greater than 6, something like 7 or 8 or 9, something that makes the denominator always positive, it's going to come out as positive 1, right? If you plug in 7 or 8 or 9 or 10, this is going to end up being positive. But the minute that you plug in something less than 6, 5.9, 5.8, 5, 4, 4.5, anything less than 6, the minute that this number on the left is smaller than the number on the right, it's going to become negative. So that means anything less than 6 will output a negative 1. So because this is a two-sided limit, because this is two-sided, that means that the limit as x goes to 6 from the right, that's going to equal to what? 6 from the right. Right, that's going to be positive 1. And then anything from the left, 6 from the left, left of 6, that's going to be negative 1 because, again, you're making the denominator go to a negative value. So the one-sided limits exist, but they are not equal, right? And for the two-sided limit to exist, the one-sided limits have to exist and be equal, and they are not. So we would say for this it's a DNE. And again, the reason it's a DNE, what we discussed in the first lecture, was that if you are approaching a gap, it's DNE. So the answer to this one is DNE because you're approaching the gap. From the left and from the right, the output values are not equivalent. Again, that's the only place on this graph where you would write DNE. So for instance, on a test for this problem, if I had said what's the limit as x goes to 8, you would say what? If you're at 8. So coming in from the left and the right of 8, you would say, oh, the height is 1. But if you're at that point where it's indeterminate, if you're at the gap point where the function gaps, that's DNE. Or depending on what side you're coming in from. If it's a one-sided limit, it actually has an answer. Two-sided limit, it does not. Okay, gang, I hope that helped. I'll catch you. Bye-bye.